Okay, so you're back with us for another deep dive, and we're going to get right into it.
Yeah.
Today, we're taking a look at something that I think could really, revolutionize
Yeah.
how we learn. And you've sent us a bunch of really fascinating material on space-guided learnography.
Yeah.
It's really a head turner,
Yes.
right? Like, we're not just talking about absorbing information, but actually how we wire knowledge into our brains.
Precisely. So it's about going beyond that traditional model of just passively receiving information.
Okay.
And it really looks at how we actively engage with knowledge and literally build understanding in the brain.
Yeah, and you sent some stuff over about this thing called the SOTIM framework,
Right.
Space Object Time Instance and Module, and it seems like that's really the core of this whole approach, right?
Absolutely. Yeah. It's
Yeah.
the underlying structure that makes space-guided learnography work. And it's
Yeah.
really fascinating how it all connects.
Yeah, and this whole thing seems to tie into these happiness classrooms and this concept of miniature schools within them.
Mhm.
So it's kind of like these learning environments within learning environments.
Right. Very much so.
So our goal in this deep dive is to really unpack what space-guided learnography is all about and how the SOTIM framework comes into play.
Yeah.
I mean, we really want to understand how this model aims to make learning not just easier, but more effective and kind of in tune with how our brains actually function.
That's exactly it. And I think one of the most crucial things to grasp from the outset is that space-guided doesn't simply refer to the physical location of learning, but it's really about a deliberate and structured approach to the process itself.
Okay, so it's not like we're just talking about going to the moon to study or something.
Right, exactly. It's not about the location as much as it's about how we use spatial design and active participation as kind of a guide for the entire learning journey.
Okay, so unpack that a little bit for me. Like when you say structured guidance through spatial design, what does that actually mean in practice?
Sure. So think about it this way. We're talking about intentionally shaping the entire learning environment. So that includes both the physical space, but also critically, the way that information is structured and presented to your mind.
Okay.
So the ultimate goal, as highlighted in the sources you sent, is active, personalized, and adaptive knowledge transfer.
Got it.
So it's moving away from that old idea of the brain as a passive container, just waiting to be filled with facts,
Yeah.
and instead embraces the concept of the brain as an active builder.
Right. So it's more about constructing understanding than just passively taking in information.
Exactly. And a couple of key concepts that really stand out in the material you shared are motor engagement and brain page development.
Yeah, those sound pretty central to this whole thing.
They are incredibly important. So motor engagement basically recognizes the power of physical activity and learning.
Okay.
It turns out that when we physically interact with what we're learning or we engage in tasks that are related to the information, it actually helps create stronger connections in our brain.
Hmm.
And then brain page development is a way of understanding how our brains organize and store new information. It's kind of like creating mental maps of knowledge.
Right. So it's like building these internal frameworks for understanding.
Exactly. And space-guided learnography is specifically designed to leverage these ideas of motor engagement and brain page development through these active physical interactions with the learning material.
Okay, so it's not just about sitting there and listening or reading, but actually doing things that help solidify that knowledge.
Absolutely.
Okay, so let's dive into this SOTIM framework a little bit more, starting with space.
Sure.
Now, you mentioned it's both physical and cognitive. So how does the design of this space actually contribute to better learning?
That's a great question. The source material really emphasizes that a well-designed learning space should promote three key elements: motor engagement, brain page making, and the ability to actually carry out learning tasks effectively.
Okay.
So imagine a learning environment that's set up to encourage movement, hands-on interaction with materials, and really focused activity. This could mean flexible room layouts, specific areas for different kinds of tasks and resources that you can actually touch and manipulate.
Right.
And the cognitive space aspect of it refers to how information is presented and structured in a way that's compatible with how our brains naturally process and make sense of new information.
Right. So it's not just about making a classroom look pretty or visually appealing. It's
Correct.
really about a functional design that pushes learners to interact with the material in a way that helps them learn.
Exactly.
Okay, so next up we have object. And the source material makes this interesting point that knowledge objects, like specific books, digital tools, and even these brain page modules, they're the things that actually hold the knowledge.
Right.
That's a kind of a unique way to think about it.
It shifts our perspective on knowledge from
Yeah.
thinking of it as this abstract concept to recognizing that it's actually embodied within specific resources and tools. So whether it's a well-structured textbook, a digital learning module with interactive exercises, or even a brain page module,
Mm-hmm.
which is kind of a mental framework, those things act as containers for knowledge.
Got it.
And the crucial part is how that knowledge is encoded and presented within these objects to make that transfer to your brain as smooth and effective as possible.
Okay, so the object is kind of like the delivery system for the knowledge.
Yeah, you can think of it that way.
Okay, so then we have time.
Right.
And that seems fairly straightforward at first glance,
Hmm.
like how long we spend learning.
Right.
But the source talks about aligning knowledge transfer with our natural cognitive cycles and this thing called motor sequencing.
Right.
So what's the connection there?
So this is about going beyond just scheduling a class for a certain amount of time. It's about recognizing that our brains have these natural rhythms of focus and attention.
Okay.
So by timing learning activities to align with those rhythms,
Yep.
we can really optimize how much we absorb and how well we retain it.
Yeah.
And that mention of motor sequencing ties back into the idea of physical engagement that we talked about earlier.
Right.
When learning involves physical actions, the timing and the order of those actions can actually make a big difference in how well the information gets encoded and remembered.
Okay.
And the source even mentions specific time blocks within these miniature schools. So there's a real emphasis on deliberately structuring the duration of learning activities.
So it's kind of like working with our internal clock instead of trying to fight against it.
Exactly.
Okay, so now we come to instance, which is described as specific learning experiences based on something called instance-guided object learning.
Right. IGLO.
IGLO, yeah. And it's all about being action-based and really activating that motor knowledge we were discussing.
Okay, break that down for me a little bit.
Sure, so instance refers to particular learning events or tasks. The key here is that these instances are very hands-on and action-oriented. So instead of just sitting and reading or listening, you're actively doing something like solving a problem, conducting an experiment, creating a presentation. Right, so it's about engaging with the material in a very active way.
Exactly. And instance-guided object learning means that these actions are often centered around those knowledge objects we talked about earlier.
Okay.
So by actively working with these objects through well-defined tasks, you're engaging those motor skills. And that really helps solidify those brain pages, those mental representations of the knowledge.
Okay, so it's learning by doing, but with a very specific focus on how that doing connects to the knowledge source itself.
Absolutely.
Okay, last but not least, we have module.
Yeah.
And this is defined as that fundamental adaptable unit of knowledge transfer. And the source also mentions that the miniature school itself acts as kind of an organizational module. So it's modular on a couple of levels, it seems.
You got it. So on one level, a big complex topic or task can be broken down into smaller, more manageable modules,
Okay.
which makes learning much less overwhelming
Right.
and allows learners to master the individual components before moving on to the bigger picture.
Right. So it's kind of like breaking a big task down into smaller steps.
Precisely. And on another level, the miniature school itself acts as a larger organizational module, a self-contained unit within that happiness classroom that's designed to facilitate a very specific type of learning experience.
Okay, so you've got these individual modules of knowledge, and then you've got the miniature school itself as a module within the larger classroom environment.
That's right.
Got it. Okay, so SOTIM gives us the blueprint.
Mm-hmm.
But now let's zoom in on these miniature schools within the happiness classroom.
Sure.
The source mentions that there are 7 of them,
Yes.
and they're described as these dynamic learning spaces for actively transferring knowledge, really helping with that brain page development and promoting self-directed learning.
Absolutely.
So this sounds pretty innovative.
It is. It's really where the SOTIM framework comes to life in a tangible way.
Okay.
So imagine these smaller, distinct learning environments set up within a larger classroom, each one designed to encourage both collaborative and individual learning.
Okay.
The source highlights 3 key functions of these miniature schools. The first one is active knowledge transfer,
Okay.
and that's where you physically interact with those knowledge objects we discussed earlier, using your body to really encode the information at a much deeper level.
So instead of just like reading a chapter in a textbook,
Right.
you might be building something based on what you read, or writing really detailed notes, or even moving around the space to complete a task related to the material.
Precisely. The idea is to engage as many senses and motor pathways as possible to make learning a more holistic experience.
Okay, so the second key function you mentioned.
Yes, so the second one is personalized learning.
Okay.
And that's because the tasks within these miniature schools are designed to adapt to an individual's pace of brain page development.
Okay.
So learners can progress at a speed that makes sense for them. If you grasp a concept quickly, you can move on if you need more time. You can focus on mastering it without feeling rushed or left behind.
Right. So that really addresses a major pain point with traditional classrooms, where everyone is often expected to learn at the same pace, regardless of their individual needs. It's exactly. It recognizes that learners are diverse and need that flexibility to truly succeed.
Okay, so what's that third key function?
So the third key function is adaptive learning.
Okay.
And this is all about getting feedback in real time and having the tasks adjusted based on your progress. So if you're struggling with a particular concept, the task itself or the resources available to you might actually change to provide more support or maybe offer a different perspective.
Wow.
It's a really dynamic system that responds to your evolving learning needs in the moment.
That's really cool. And the source mentions that each of these 7 miniature schools has a task moderator, which is the subject teacher,
Right.
who kind of keeps an eye on everything and makes sure those SOTIM principles are actually being followed.
Yes, exactly.
So it's not just like throwing everyone into a room and seeing what happens.
No.
There's still guidance and structure. Absolutely. The teacher's role shifts from being the primary source of information to more of a facilitator or a guide, supporting the learning process within each miniature school and ensuring that the SOTIM framework is being applied effectively.
Okay, so we've got a good handle on the theory now.
Right.
But let's talk about how all of this actually works in practice.
Yeah.
So let's walk through those practical points that the source highlights, starting with spatial organization within the happiness classroom itself.
Okay, so the source describes a classroom that's intentionally divided into different task zones,
Okay.
clear movement pathways, and designated knowledge pods.
Okay.
So picture different areas in the room set aside for specific types of activities.
Okay.
Maybe you have a quiet zone for focused reading a collaborative space for group projects, and then easily accessible knowledge pods, where learning materials and digital resources are located.
Okay.
This structured layout is very deliberate. It's all about supporting that active and engaged learning that space-guided learnography emphasizes.
Right. So the design of the physical space actually plays a really crucial role.
Absolutely.
Okay, so next is object interaction.
Right.
We've touched on this a bit already, but the source really hammers home the point that learners in the system, they actively engage with those transfer books and those knowledge modules.
Right.
They're basically turning information into something that they can physically do or understand on a motor level.
Yes.
And it really stresses that the object itself holds the knowledge that needs to be transferred.
That's a really important distinction. It's not just passively absorbing information from the object. It's about actively working with it, transforming it into something tangible, something you can manipulate or apply.
Right, so it's not just about reading the textbook.
Right.
It's about doing something with that information.
Exactly. And that active engagement, whether it's taking notes, building a physical model, or interacting with a digital simulation,
Yeah.
that's what really leads to the development of that motor knowledge and a much deeper level of understanding.
Okay, so then we have temporal flow, and the source mentions that learning tasks are sequenced to align with time, and something called thalamic cyclizide rehearsals.
Yes, PCR.
PCR.
That sounds a bit technical, but it's actually a really fascinating concept.
Yeah, so for someone who's not a brain scientist, break that down a little bit.
Sure. So basically, your brain has these natural cycles of activity times when it's more primed for learning and memory formation.
Okay.
And TCR refers to these rhythmic patterns of neural firing.
Okay.
So the idea is to sequence learning tasks in a way that incorporates repetition and aligns with these natural brain rhythms.
Okay.
It's almost like hitting the right note at the right time, making the repetition more effective for encoding the information.
So it's like our brain has a natural learning tempo.
Yeah.
And this approach is trying to sync up with that.
Precisely.
Okay, so then we have instance execution,
Right.
which involves creating these clear learning paths with specific goals and then actively carrying out those learning experiences.
Yeah.
Like that brain page construction that we talked about through these defined tasks. And this ultimately leads to refining your skills.
Learning isn't just about accumulating facts. It's about developing abilities and knowing how to apply what you've learned.
Right.
So instance execution focuses on setting up these clear pathways with specific learning objectives, and then you engage in defined tasks the instances that require you to actively use the knowledge that you're gaining.
Got it.
Even the process of brain page construction can be seen as a series of these task instances.
Okay.
And through practice and refinement of how you perform those tasks, your skills develop
Yeah.
and the knowledge becomes more deeply embedded.
Okay. So, and finally, we have modular adaptation.
Right.
So those miniature schools, they're designed to adapt to how well each learner is progressing,
Yes.
allowing for that personalized advancement that we talked about.
Exactly.
And then complex tasks are broken down into those smaller modules
Right.
to make learning faster and more efficient.
That's nice.
So it's adaptable both on that small scale of individual tasks, but also on that larger scale of the entire learning environment.
That's right. The system is designed to be incredibly responsive if you're excelling in a particular area. The miniature school environment can offer more challenging tasks or allow you to move through the modules faster. And on the flip side, if you're finding something difficult, it can provide more support or break things down into smaller steps.
Right. So it's all about meeting the learner where they're at.
Precisely ensuring that the learning journey is tailored to individual needs and ultimately leads to mastery.
So, I mean, this really paints a picture of a very different kind of learning experience than what most of us are used to.
It does.
So looking ahead, the source material really highlights how space-guided learnography and the SOTIM framework really transform the whole academic experience from something that you passively listen to
Right.
something that you actively do.
Absolutely. That's the core transformation.
Yeah.
It's about empowering learners to be active participants in their own education rather than just recipients of information.
Right. So it's about taking ownership of your own learning.
Exactly. And by engaging both your mind and body, you create a much deeper and more lasting understanding.
And these miniature schools are presented as these personalized and adaptive centers for really developing those brain pages
Mm-hmm.
and ensuring that every learner can achieve mastery. So it's not just a different way to set up a classroom. It's really a whole different way of thinking about learning itself.
It is. It's a potential paradigm shift. And the source even positions this not just as a classroom model, but as a potential future for education more broadly.
Yeah, and the source concludes with some really clear calls to action.
Right.
You know, rethinking our learning spaces, actively engaging our bodies in the learning process, and making the whole learning journey much more personal.
Absolutely. It's a challenge to both educators and learners to re-examine our assumptions about how learning happens and what kind of environments best support that process.
So to sum it all up, this deep dive into space-guided learnography powered by the SOTIM framework really highlights a potentially revolutionary approach to learning.
Yeah. It's about working with the brain's natural mechanisms instead of trying to force information in.
Absolutely. And by thoughtfully structuring the learning environment, from the physical space to the knowledge objects to the timing of learning and the activities themselves, this approach aims to create a much more effective, engaging, and ultimately successful learning experience for everyone.
And the source concludes with this really thought-provoking idea
Mhm.
that every learner deserves an environment that works with their brain, not against it.
That's a powerful statement.
It is. It really makes you think, are we ready to embrace this potential future of education?
It's a question worth pondering, and for anyone listening who's thinking, okay, I want to learn more, the source mentions something called the Takshila page as a place where you can find more information on system learnography.
Okay.
So that might be a great resource for anyone who wants to dig deeper into these concepts.
Yeah, absolutely. So go check that out. Continue your own deep dive. And thanks for joining us as we explore this really fascinating topic.
Yeah, this was great. Until our next exploration, keep learning and keep questioning.
Excellent.